Newton's first law, the law of inertia, states that an object does not change its state of motion unless acted on by an external force. For example, a ball cannot be thrown unless pushed or launched by an external force.
Another example which I deem much more interesting is a classic magic act. I may not be able to execute this at a high level, but Newton's first law remains clear. As you can see, the plate remains largely in its original position. This is because the plate's inertia causes it to resist the rapid change in motion. The slight movement is due to the friction and the force that was transferred from the cloth to the plate.
This also brings me to the topic of relation between inertia and mass. The relationship is directly proportional because mass is the measure of inertia. So the greater the mass, the greater the inertia. Now, realizing that some of you may not know exactly what inertia is, well, inertia is the property of an object to resist any change in motion. So basically, inertia is one of the reasons why an object stays still.
Hey, so next we'll be going over Newton's second law of motion, also called the law of acceleration. Basically, this law states that the acceleration of an object depends on the net force applied to it and its mass. The formula is F is equal to m times a. Force is equal to mass times acceleration. Basically, if you push harder, it speeds up more. But if you use that same push on a heavier object, it's not going to move that much. Let's test it with this toy car. When I give it a light push, it moves a little and slows down quickly, which is small acceleration. But if I push it harder, it speeds up much faster, which is bigger acceleration. That's Newton's second law of motion in action. More force means more acceleration. Now, let's think about what happens in each direction. The x direction, which is side to side, my push gives that car acceleration forward. And the y direction, which is up and down, gravity pulls it down, and the table right here acts up on it, canceling those two forces out. Basically, in the y direction, it's in equilibrium, but in the x direction, it's accelerating this way. That's why the acceleration only happens in the x direction and not the y. So, to recap, Newton's second law of motion explains how motion happens when a force acts on an object. The toy car accelerates forward because that's where the net force is. Vertically, the forces balances out, so there's no acceleration there. In short, forces causes acceleration, mass resists it, and direction decides where it goes.
Okay, so basically, I'm gonna explain Newton's third law. And basically, it's about how, like, whenever an object, like, exerts a force, the other object, like, exerts a force back in the opposite direction. So, like, for example, when you push a wall, the wall, like, exerts force back on you, but, like, it doesn't move, but it still exerts force back on you. And it basically explains, like, well, physics, duh. So, like, another example is, like, with a rocket, whenever it goes up, and then the forces are pushing, like, for the exhaust to push down, which helps it go up, if that makes sense. So, basically, like, it's just action and reaction. So, like, there's always gonna be a reaction to when you do something. So, like, I'm gonna do a balloon, and the action is gonna be me having, like, the balloon, and the reaction is gonna be the air, like. That's the reaction.